Today we're going to talk about powers of 10, but we're going to talk about it in a little bit of a different way than we did at the beginning of the year. So I'm going to go ahead and write the date in my notebook. And this is MBT 1 and MBT 2. This is going to be page 25 for me. That was our first powers of 10 notes that we did. We talked about just the difference between how when we go in our place value chart, the number gets larger, it gets smaller in certain places. Okay. If we look here, we have, we're going to talk about powers of 10 with decimals. I want you to think of an equation you could write to get a product of 100 or 1,000. And the trick to this equation is you have to multiply, because you're trying to get a product of 100 over 1,000. Only using tens in your equation. Okay, only using tens in your equation. So I can only use tens in a multiplication equation, and I want to get an answer of 100 or 1,000. Okay, you can pause the video to think about it, or if you're not sure, you can keep playing the video to see how you can do that. Okay, if we take 10 times 10, 1 times 1 is 1, 0, 2 zeros, we get 100. So that's a way to get a product of 100. Oops, I wrote 100 twice up here. I meant to put 1,000. All right, how do we get a product of 1,000? Well, if I take 10 times 10, I know that's 100. And if I multiply that 100 times 10 more, then I get 1,000. So 10 times 10 times 10 equals 1,000. Notice this does not equal 30. I'm not saying 10 plus 10 plus 10. I'm saying 10 times 10 times 10. Okay, because if I think about this first 10 times 10, that's 100, and then I have another times 10 to finish off with, which gives me the 1,000. Okay, we're going to take a look at this page that you should have with you, Exploring Powers of 10 from day 23. And we know 10 times 1 is 10. Okay, we just explored 10 times 10 was 100. We also explored that 10 times 10 times 10 is 1,000. Okay. If we look at the next one, 10 times 10 times 10 times 10, basically multiplying 10 by that same number 4 times. Okay, not 10 times 4, but 10 times itself 4 times. I know that 1 times 1 times 1 times 1 is just 1, and then I have to add 1, 2, 3, 4 zeros. So that is 10,000. If I look here, I know I'm going to have a 1 to start with, and I need 1, 2, 3, 4, 5 zeros. So that's 100,000. If I look here, I know I'm going to start with a 1 because 1 times all these other 1s is just going to be 1. And then I add my zeros. I have 1, 2, 3, 4, 5, 6,000, or 6 zeros, I'm sorry. That makes 1 million. And if I look here, I have 1, 2, 3, 4, 5, 6, 7 zeros. So 1 and 2, 3, 4, 5, 6, 7 zeros. Every 3 I make a comma. That makes 10 million. Okay? So it grows by a 0 each time. If you notice that pattern going down, it grows by 1 0 each time. Okay? I notice that my 1 shifts over one place value to the left, meaning that my number gets larger each time. Okay, that 1 was right here is in the tens place, the 1 right here is in the hundredths place. The one right here is in the thousands, then the 10,000s, then the 100,000s, then the millions, then the 10 millions. So each time I'm multiplying by another 10, my 1 shifts to the left and gets larger on my place value chart. Okay? Now, if we try to think of powers of 10, powers of 10 are like exponents, okay? And I'll say that word for you, or write that word for you. They're like exponents. And exponents basically tell us how many times to multiply a number by the number that we're looking at. So we're going to go ahead and put 10 in all of these because we're going to do different powers of 10. And the way I can determine my exponent is to determine how many times I multiplied 10 by itself. Well, here only multiplied 10 by itself 1 time. So my exponent, and it's a little number that kind of goes right on top right there, kind of sits up on that 0, is the number 1. Here I multiplied 10 times itself 2 times, 10 times 10. 2 times I see 10 there. So I put a number 2 up here. Okay, here I multiplied 10 by itself 3 times, so I'm going to put a number 3 right here. Okay, here I multiplied 10 times itself 4 times, 1, 2, 3, 4, so I'm going to put a 4 right here. I did it 5 times here, 6 times here, and 7 times here. So the way I would say this is 10 to the first power. That's how you read exponents. This second one would be 10 to the second power. The next one would be 10 to the third power. Here would be 10 to the fourth power. Here would be 10 to the fifth power. And this would be 10 to the sixth power, 10 to the seventh power. Okay. I want you to pause the videos and I want you to describe any patterns you see in this column. What patterns do you notice kind of that we talked about? I discussed a few of them previously, but put in your own words at least 2 patterns you noticed in the evaluate column. And here, describe what you notice in the powers of 10 column. I want you to put at least 1 pattern you notice, at least 1 pattern you know down here that's from this column that you see going down. Okay? You can pause the video to go ahead and do that. Okay. Now we're going to take a look at, and notice that 10 to the first power is 10. 10 to the second power equals 100. 10 to the third power equals 1,000. 10 to the fourth power equals 10,000. Okay? This is like the shorthand version. This is the expanded version, and then this is our answer. Okay? All right, we're going to take a look at your next page, and your next page is exploring multiplying by a power of 10 with whole numbers. Okay? So it gives us an example, 25 times 10 to the first power. Well, how do I write that? Well, I've got to think about what does 10 to the first power mean. It really means multiplying 10 by 10 1 time, okay? Because that power tells me how many times I'm multiplying by 10. So that would be 25 times 10. Well, 1 times 25 is 25 and add my 0, okay? Now, 25 times 10 to the second power is a little different. This second power tells me that I need 2 10s multiplied in my equation. So that means I have 25 times 10 times 10. Okay? In other words, if I think about just these 10s, that means I have 25 times 100. 1 times 25 equals 25, and then I add 2 more zeros. So that equals 2,500. Now, 25 times 10 to the third power. This is 25, and how many 10s do I need to multiply with? I need to multiply with 3 10s. So it's times 10, times 10, times 10. So what does that really equal? Well, it equals 25 times, I have 1, 2, 3 zeros, so times 1,000. And that equals 25,000. Okay. 25 times 10 to the fourth power means I have 25 times 4 10s. I need to put 4 10s in my equation. So 1, 2, 3, 4. What does that really equal? Well, it equals 25 times, if I look at just my tens together, that'd be 1 with 1, 2, 3, 4 zeros. So that's 25 times 10,000. So that becomes 25 with 1, 2, 3, 4 zeros, which is 250,000. And notice I'm really relying on my power of zeros. I'm not having to remember a whole lot of facts right here. I'm thinking about zeros and how much power they have as a number. Okay, 25 times 10 to the 5th power is 25 times 10, 5 times. So 1, 2, 3, 4, 1, 2, 3, 4, 5, which really equals 25 times, and since I have 5 tens there, I know I'm going to have 5 zeros. 1, 2, 3, 4, 5. So that's 25 times 100,000, which equals 200 or 2,500,000. Because I need 1, 2, 3, 4, 5 zeros. Because I had 1, 2, 3, 4, 5 zeros I multiplied with. Okay? I want you to study over that and come up with at least 2 patterns you noticed on this chart. What patterns do you notice as we multiply, as we increase our powers of 10 that we're multiplying by, what happens to our products? Okay? As the powers of 10s we're multiplying by increases, what happens with our products? I want you to think on what that actually means. Okay? You can pause the video to do that. And then come up with your 2 patterns and write them here, at least 2 patterns. All right? Now, we're going to move on to our last page here. And this is actually multiplying decimals by powers of 10. Okay? So this is 39 and 45 hundredths times 10 to the 1st power. So if I think about what does that really mean? That really means 39 and 45 hundredths times 10. Okay? Normally, we would take that number, multiply it by 1, add a 0 in the end, and be okay. However, when we have decimals in our equation, we have to make that number shift because we noticed in our other sheets that we did, numbers shifted to the right on our, to the left on our place value chart and got larger when we multiplied by powers of 10. If we just stick a 0 on the end of here, it's not going to get any larger. It's not going to change the value. So our numbers have to shift over in place value. Okay, so what this ends up equaling is 394 and 5 tenths. Okay, why is that the case? Well, if I look over here, if I have a tens place, a ones place, there's my decimal, a tenths place, and then a hundredths place, and I'm going to come right here and add a hundreds place to the front. I forgot to add that. I started off with the number 3 in the tens, 9 in the ones, 4 in the tenths, 5 in the hundreds. Now, because I'm multiplying by 10 to the 1st power, or times 10, my digits are all going to shift, my numbers are all going to shift 1 place value to the right, or to the left, excuse me. So it's going to get 1 place value larger. Because remember, here, when I multiplied by powers of 10s, my ones, each time I multiplied by a new power of 10, my 1 shifted over 1 place value to the left. Okay? So here my numbers are all going to shift 1 place value to the left. So the 3 moves to the hundreds, the 9 moves to the tens, the 4 moves to the ones, and the 5 moves to the tenths. Why did it shift just 1 place? Because I multiplied by 1 power. I had 1 power of 10, or multiplied by 1 time. Okay? Here, when I look at my next example, my digits will shift 3 places because I have the power of 3 in my number, or 10 to the 3rd power. So it'd be 9 and 78 hundredths times 10 to the 3rd power. Well, that really equals 9 and 78 hundredths times 10 times 10 times 10. Again, if I just add those 3 zeros to the end, it doesn't change the value. And I know multiplying by 10s is actually going to make my value larger. So that means all my digits have to shift 3 place values over. That means I end up with 9,780. I'm going to show you how that works over here. So I'm going to have a thousands place. I'm going to have a hundreds place. I'm going to have a tens place, a ones place, a tenths place, and a hundredths place. And I'm just going to have to label that HUN, okay? My original number was 9 in the ones, 7 in the tenths, 8 in the hundredths. Well, because I multiplied by 3 tens, I had 3 sets of tens in my equation, or to the third power, that means every number had to shift 3 place values. So the 9 shifted 1, 2, 3 and ended in the thousands. The 7 shifted from the tenths, 1, 2, 3 to the hundreds. The 8 shifted from the hundredths to 1, 2, 3 to the tens. And then I put a 0 right here to complete my number. So I end up with 9,780. I want you to try one other problem to complete on this page, one of these two. Try to complete one other problem and show the place value drawing like I have. I know this video was long, so if you finished all the notes and have all of them done and I check over your work, then you will receive 5 tickets from me tomorrow. Awesome job.